Hello and welcome to Easy Maths. In this video, we're going to look at examples that have to do with inverse of matrix as we continue in a series of lessons on the area of matrices. Please like and share and also subscribe to my channel so that you can be able to access my content that I'm going to be developing and also math that I've developed in the past years. Now we're told determine the inverse of following matrices. And the first one we're given there is 7, 9, 3, 4. As we do this, we need first of all to look for the determinant, and we said it is the product of the elements and leading diagonal minus the product of the other elements, which is in our case 7 times 4 minus 3 times 9. The answer is 1, and therefore inverse will be the reciprocal of this determinant times the transposed matrix, which is just 1 over 1 times transposed means 7 and 4 are reversed, so that you have 4 and 7, and the 3 and 9, their signs are reversed. 7 and 4 are interchanged, but the signs for 3 and 9 are reversed. So that's what we have here. And therefore, the matrix would simply be 4, negative 9, negative 3, 7. Another example for us here, we have 6, 13, negative 2, negative 4. Again, the determinant will be 6 times negative 4 minus 13 times negative 2, and the answer will be 2. The determinant is 2. Therefore, the inverse will be the reciprocal of that 2, that is a half, then times the transposed matrix, so that you have 6 and 4 are reversed or they interchanged like this, and then the signs for negative 2 and 13 are reversed. The 2 was negative, it becomes positive. 13 was positive, it becomes negative here. And therefore the matrix would simply be negative 2, negative 13 over 2, 1, 3. This is the inverse of the matrix 6, 13 minus 2 minus 4. Please notice that however way you multiply the inverse with the matrix we had at the beginning, you'll always get the identity matrix 1, 0, 0, 1. Another interesting example, we have 3, 5, 9, 15. We are looking for the inverse of this particular matrix. Now look here. The determinant is 3 times 15 minus 5 times 9. And both of these are 45. Therefore, 45 minus 45 is 0. That means the determinant is 0. Now, if the determinant is 0, therefore, we should note two things. One, the matrix has no inverse because it also has no determinant. What I mean is that the determinant being 0, the inverse will be 1 over 0, which is an ambiguous case in mathematics. So therefore, that matrix has no inverse. Again, another thing, whenever a matrix has no inverse, it's normally called a singular matrix. So those two important points should be noted there. This particular matrix has no determinant, or the determinant is 0. Therefore, the inverse is 0, or it has no inverse rather, and the matrix is a singular matrix. Now, another last example, we have the matrix which has the fractions. We're going to have the determinant first of all, which is half times a quarter minus a quarter times an eighth, and the answer will be it's operated like this here, and we have the answer is 3 over 32. The determinant being 3 over 32 means the inverse will be the reciprocal of this times the transposed matrix, and therefore we have the inverse as 1 over 3 over 32 times the transposed matrix, where we have the half interchanged with a quarter. So we have a quarter and half. The signs for a quarter and an eighth are reversed. They're both of them positive. We're going to have both of them negative here. And of course, we simplify. This double reciprocal here should be simplified to be 32 over 3, then times whatever we have here, and simplify that. The answer will be 8 over 3 minus 4 over 3, 8 over 3 negative, and 16 over 3. And that brings me to the end of that particular lesson, where we were looking at the examples of inverses, or questions that have to do with inverse of given matrices. Please check out now for the next couple of lessons, where we're going to be looking at the application of the inverse of a matrix in solving simultaneous equations. Check out for that, and as always, please like, share, subscribe, and appreciate. Thank you.